let's go ahead and get started. So we're going to be looking at rates of change. So what is a rate of change? So a rate of change is a rate that describes how something changes in response to another. So when we think about a rate, that's some type of number, it's some type of description that tells us how something changes. How do my students' test scores improve with the style of teaching that I changed? Or how do you get faster if you take an energy drink or you don't take an energy drink? So there's a response to something that has happened. So we have this little triangle and you're like, that's just a shape. Or it can mean delta, which it does, but in math world, delta means change. It's not anything to do with a fraternity or sorority. Rate of change it's the change in dependent over the change in independent, or it's the change in y over the change in x. Those mean the same thing. Dependent goes with the y variable, independent goes with the x variable. Those are just different ways to write it or different ways that you could possibly see it. So, why do I even need to know this? Okay, it tells us when something's linear and when it's not linear. So what do those words even mean? So linear is a function. Remember, a function is where the x values do not repeat. Is linear if the rate of change between any and all points is the same. So that means it's a constant rate of change. So that means it's the same no matter where you go on your graph or no matter where you go on your table, it's the same change from one point to another. And so a linear graph is going to have a straight line. It's going to produce a straight line every single time. What I mean by a straight line, you see how there's no breaks on that line? It's not a V, it's not curved at all, it is just one straight line. And on a table, you'll notice, let me go backwards. So if you'll notice how it goes up one, right one, the same one every single time. That's how you know if it's has a constant rate of change, just going up and down or left and right by the same number every single time. Now, table. How do I go from 1 to 2? I add 1. Same idea from 2 to 3, I add 1. 3 to 4, I add 1. That's my change in x. Now looking at y. To go from 2 to 4, I add 2. 4 to 6, I add 2. 6 to 8, I add 2. So you're looking at just like them separately. So just look at your x values, and you look at your y values, because you may be thinking, wait a minute, you said it has to be the same on both. It's got to be the same for your x values and then same for your y values. So these are different, and that's totally fine, because what you'll notice is the change in y every time is 2. So if you'll notice 2, 2, 2, and the change in x is 1 every time, 1, 1, 1. So they're the same for each variable. So constant rate of change. Now nonlinear. Nonlinear is a function is nonlinear if the rate of change is not constant and produces a non-straight line. What that means is if you look at these right here, do you see how it goes down and all of a sudden it's increasing? If it is a constant rate of change, it's not going to increase then decrease. It's either going to decrease continuously or it's going to increase by the same number continuously. And again, the same thing here if it has any type of curve. So here I'm going down 2, right 1, and here it's down 1, right 1. Different rates of change right there. And you don't have to count. If your graph has any type of break in it, any type of curve to it, it is a nonlinear line. Okay, and now we're going to look at our table. So how do you get from 1 to 5? You add 4. You can subtract. It may not always be that you're adding something. It could be that you're subtracting. Both is fine. From 5 to 7, you add 2. From 7 to 9, you add 2. So I already see 4, 2, and 2 are different numbers, but you check to make sure that your fractions are the most simplified form. So we'll look at that in just a second, just to be sure. So you go from 1 to 3 by adding 2, 3 to 5 by adding 2, and 5 to 7 by adding 2. So all my y's are the same. So what that leads me to is, if you see, it's the change in y over the change in x. So that's 2 over 4. Okay, 2 over 4 reduces to 1/2. Then we have 2 over 2. 2 over 2 reduces to 1 over 1. And then we have 2 over 2 again, which reduces to 1 over 1. So 2 of these are the same, okay, but 1 of these, so 2 of these are 1 over 1, and 1 of these is 1/2. If you'll notice that they're not all 1 over 1 and they're not all 1/2. So that means that I have a different rate of change for one of my numbers. So that means it is non-linear since it did not have the same rate of change. So here's what you're going to do. You're going to practice. So for the graphs, you're simply going to label them linear or non-linear. And for the tables, you're going to identify their rates of change, like how we did on right here, how you counted from one number to the next. And you're going to identify if they're linear or non-linear. It's linear if it has the same numbers increasing and decreasing every time. And it's non-linear if they don't. So here's what you're going to do. You're going to press pause, and when you're ready to see the answers, press play. Hi! So let's check out your answers. So this first graph is non-linear. It has that break automatically, we know. Linear is the horizontal line because think about a function. Okay, this is a function 100% because if I draw a vertical line, it only touches it one time. It's also that it's a straight line. You see how nothing's broken on there? Like it doesn't curve at all, anything. I know it looks kind of weird that it's a horizontal line, but it is linear. And then we have this one, it's linear, and then non-linear, because you can tell it breaks two different times. What I mean by break is it goes from here, so there's break one, then it goes to a different direction, break two, okay? So now, looking at your rate to change, I have 3/2 for all of these, so it is linear. Looking at this second one, it's 2/1, so let me show you with my arrow, 2/1, 2/1, 2/2. So I have a rate of change of 2/1 and a rate of change of 2/2. If you'll notice, one reduces to 2 and the other reduces to 1. Those are not the same, so it is non-linear. Now looking at this one, I have 2/3, 2/3, and 4/6. You're like, oh, nope, that is automatically non-linear. But remember, you gotta have it in its most simplified or most reduced version. So 2/3 and 4/6. 4/6 and 2/3. 2/3 is the reduced form of 4/6. So it's like they skipped a value. So instead of it going from 3, 6 to 3, 6, 9 to 15, it could have gone 3, 6, 9, 12, and then 2, 4, 6, 8. So it does have a constant rate of change because that 4/6 reduces to 2/3, which is the rate of change you can see in the top two. So again, a couple reminders are it can be subtraction that you go from one to the other with. That's totally fine. It has to be a constant rate of change for it to be linear. Okay, so keep that in mind. You are gonna be great, y'all. Thank you.